Welcome to the Blue Collar Tutor Test Preparation Series for the New York City Fire Department, S-13 Certificate of Fitness for Citywide Supervision of Standpipe Systems, and the S-14 Certificate of Fitness for Citywide Supervision of Multi-Zone Standpipe Systems. It is critical that you understand this material to pass the exam. If you haven't already, it is recommended that you watch the brief overview video at the beginning of this series before moving on to the subsequent volumes. After an initial run-through of the entire series, refer back to each of these volumes, as often as needed, until you are confident with the material covered in each section. Once you become proficient with all of the material in this course, continue on to the S-13 and S-14 practice test sections to test your knowledge of the material. Chapter 7. Different Types of Standpipe Systems. 1. An Overview of Standpipe Systems. Standpipe systems are an important part of the fire protection system in a building. The standpipe system provides water that firefighters manually discharge through hoses onto a fire. The water is fed into a piping system. The piping runs vertically, up and down, and horizontally, side to side, throughout the building. The piping running vertically is usually called a riser. Risers are usually located in the staircase enclosures or in the hallways in the building. This piping system supplies water to every floor in the building. When a standpipe system is installed and properly maintained, it is a very effective method for extinguishing fires. A multi-zone system is a standpipe system that is vertically subdivided, as required by the construction codes, into zones to limit the maximum operating pressure in the system. Each zone will have its own individual automatic water supply. Standpipe zone heights are limited to 300 feet. All zones serving occupied floors located higher than 300 feet shall be provided with primary and auxiliary water supplies. For example, a 50-story building may have a low zone ranging from the first floor to the 25th floor. A fire pump on the first floor supplies floors 1 to 25. A fire pump on the 25th floor supplies water from the 26th floor to the roof. Each zone may have its own fire department connections. The design of the multi-zone systems varies from building to building. The S-14 Certificate of Fitness holder must be familiar with the system design and must be immediately available to assist the fire department in the operation of the system in the event of a fire. 2. Classes of standpipe systems. Standpipe systems are classified depending on who is expected to use the system. The three classes are: Class 1. This system is designed to be used by the fire department. The fire hoses in these systems are 2.5 inches in diameter. The large hose diameter makes it difficult to control the stream of water from the hose. Class 2. This system is designed to be used by the occupants of a building. The hose and nozzle are connected to the standpipe. They are ready to be used by occupants in case of a fire. This hose is 1.5 inches in diameter. The stream is easier to control than the Class 1 hose. Class 3. A system that provides a 1.5-inch hose stations to supply water for use by trained personnel, and a 2.5-inch hose connections to supply a larger volume of water for use by the fire department. 3. Wet automatic standpipe systems. This system always has water in the piping. The water in the system is always under pressure. In some cases, a fire pump may be used to increase the water pressure. The wet standpipe system is the most commonly used standpipe system. It is used in heated buildings where there is no danger of the water in the piping freezing. Any part of the standpipe system that is exposed to freezing temperatures should be insulated. It is very important that the water in the piping does not freeze. Frozen water may prevent the standpipe system from working. 4. Wet manual standpipe systems. A manual wet standpipe system is connected to a small water supply for the purpose of maintaining water within the system or sharing a water supply with an automatic sprinkler system, but not having a water supply capable of delivering the demand required for the system. 5. Dry automatic standpipe with an automatic dry pipe valve. This system is usually supplied by a public water main. Under normal conditions, there is no water in the piping. Instead, there is air under pressure in the piping. A dry pipe valve is installed to prevent water from entering the standpipe system. The dry pipe valve is designed to open when there is a drop of air pressure in the standpipe. When a hose is opened, it causes a drop in air pressure in the standpipe system. Then the dry pipe valve automatically lets water flow into the standpipe. A control valve is installed at the automatic water supply connection. This valve should be kept open at all times to supply the standpipe system. This system is usually installed in a building that is not heated. The air pressure is usually set at 15 to 20 pounds per square inch above the normal trip level. Some valves are specially designed for low pressures. In all cases, the manufacturer's instructions regarding pressures to be maintained shall be followed. A drop of pressure in the piping will cause the clapper to open. An open valve is said to have been tripped. Quick opening devices are used to reduce the time needed to open the clapper and allow water into the system. These devices are an accelerator and an exhauster. They are both automatically activated when a drop of 2 pounds per square inch in air pressure is detected in the system. This change trips the dry pipe valve, allowing the water to force its way through the sprinkler piping in less time. The failure of an accelerator or exhauster to operate will increase the normal tripping of a dry pipe valve. 6. Dry manual standpipe with a manual control valve. This system is supplied by a public water main. Under normal conditions, this system has no water in the piping. The water is not allowed into the standpipe until a control valve is manually operated. The control valve remains closed until a fire occurs. The air in the piping is not under pressure. This system is usually used in a building that is not heated. 7. Dry manual standpipe with no permanent water supply. Under normal conditions, this system has no water in the piping. Water is pumped into the standpipe system by the fire department through the fire department connection. This system cannot be used unless water is supplied by the fire department. A sign reading: "Dry standpipe for fire department use only," must be attached to each of the hose outlets. This system is usually used in a building that is not heated, such as unoccupied buildings and parking garage structures. Special care must be taken when using a dry standpipe system. The nozzle must never be pointed at the fire until all of the air has been drained from the system. Otherwise, pressurized air would be discharged onto the fire, causing the fire to burn more intensely. 8. Semi-automatic dry standpipe system. A standpipe system permanently attached to a water supply that is capable of supplying the system demand at all times, arranged through the use of a device such as a deluge valve, which requires activation of a remote control device to provide water at hose connections. 9. Yard systems. A yard hydrant system is most often used in large private manufacturing plants or storage buildings. The yard system is often needed because the public water supply does not meet the needs of the fire protection system. The yard system usually has several private water sources supplying the total fire protection system. The total system may have a sprinkler system, hydrants, and a standpipe and hose system installed. The water supply sources are all connected together in the yard system. This allows the water to be directly supplied to any part of the system when needed. Water can be supplied even when one of the supply sources is not working. The combined sources of water keep the water pressure in the system at a high level. Public waterworks connection. The street main supplies water using the water pressure in the public waterworks system. Sometimes a street main may not be connected to the system if it is located too far away from the building. Pressure tank. This tank may supply water to the yard system under pressure. The tank is filled with water and air. The air forces the water out under pressure when part of the fire protection system is activated. The water supply sources are all connected to a main water supply grid. This supply grid surrounds the entire building. Control valves are installed at various locations on the system. These valves are called post indicator valves. As the name suggests, they indicate the position of the valve using a target that is visible through a window on the valve body. The valves are manually operated. Under normal conditions, the post indicator valves are sealed open. The PIVs allow the fire department to shut down all or part of the system. The post indicator valves are also used to shut down parts of the system when conducting repairs and maintenance. The water in the yard system is not allowed to flow into the public water system. It is prevented from doing so by a check valve. Several supervisory and alarm devices are usually installed in the yard system. They indicate when there is a problem with the equipment. They also indicate when water flows through the yard system. These devices are needed to make sure that the system will work properly in case of a fire. The supervisory devices may be connected to a central station company. The central station company is automatically notified when there is any problem with the yard system. It will then notify the local firehouse. When post indicator valves are installed in yard systems, they shall be painted red. Hydrants may be installed on some yard systems. They allow the fire department to run hoses from the private water mains. The location of the hydrants will depend on the layout of the building yard supply system. 10. Combination/combined systems. It is not uncommon to find occupancies having a combination of systems for fire protection. Examples of combination systems: A. Combination wet standpipe and dry standpipe system. B. Combined wet standpipe system and automatic sprinkler system. A standpipe system having piping that supplies both hose connections and automatic sprinklers. Each connection from a standpipe that is part of a combined system to a sprinkler system shall have an individual control valve and check valve of the same size as the connection. 11. Pre-action standpipe systems. Pre-action systems are designed for situations where there is danger of serious water damage. Water damage is usually caused by damaged standpipe piping. Under normal conditions, there is no water in the piping. The air in the piping may or may not be under pressure. A pre-action valve prevents the water from entering the system. The valve is automatically opened when an electrical or hydraulic release is manually activated. Alarms are standard accessory equipment on pre-action valves. They provide an audible signal in the building if the valve operates for any reason. The alarm is enunciated if a problem is discovered with the equipment. The alarms can send a signal to a central station company or a public fire alarm system. Often the signal is sent to both the central station company and the public alarm. This concludes Volume 3. Repeat each chapter as often as needed until you are confident with all of the material. A transcript of this material is provided for free by the New York City Fire Department. See the link in the description below to upload the transcript and additional reference guides that you'll need to familiarize yourself with in preparation for the exam. Post any follow-up questions in the comment section below. Subscribe to stay current on updates to existing exams and to be notified of new test preparation content. If you found this video helpful, please consider leaving a like. Thank you for watching.